Hi, my name is Simon Coter, and I'm Director of Product Management for Oracle Linux and Virtualization at Oracle. So today I'm going to share with you how to automate your infrastructure as a code and configuration management. So let's immediately start to give a quick look to the application deployment in the time, right? So here we have a timeline showing different models that have been adopted in the past on the application deployment, starting from 90, where at the end we introduced obviously the manual software installation, arriving to today, where for example, on Oracle Linux KVM, we have KVM templates that allows you to rely on ready-to-run machines that can be deployed on top of the KVM hypervisor. As we said in the 90, here I identified a picture to really share with you what was happening at that time. At the end, we were used to proceed on different installation steps, starting from the installation of the operating system to then possibly install the Oracle database or the database and the application on top of it, to then possibly even patch this kind of installation that had been executed on our system. And this kind of thing, or this kind of process, could take weeks, if not months, at the end to really deploy the service. And we know this kind of manual approach also has different and possible human errors. So human errors are around the corner, because with many different steps that have to be manually executed, it's quite easy or very easy to possibly see an error happening there, an error that at the end could again get you in trouble and maybe get you losing much more time than expected. Later, around 2000, we introduced the Oracle VM. And with Oracle VM, we also introduced the concept of Oracle VM templates. Oracle VM templates at the end were ready to run virtual machines that can be deployed on top of the Oracle VM hypervisor. And over there, we also had ready to run solution with different Oracle products, for example, covering the Oracle database, as well as others like eBusiness Suite and more. Arriving to today, DevOps is a concept that is there from different years, right? But there are some principles that at the end have to be there to really see DevOps in place. And one of them, and maybe this one is also the most important, is related to the EV automation, right? So the opportunity to possibly automate any kind of manual steps or any kind of step that was previously executed manually. That said, there are other principles that have to be there, right, to just follow the DevOps model. You're required to have a cloud-like infrastructure. You are usually required to leverage open source solutions. Something has also to change within a company, because it's also required to have an open culture. And obviously, you're also required to have their agile methodologies, or these kind of methodologies have to be in place, right? DevOps introduce also some implication to the business. One of them is related to the time, right? So higher or longer is the time to market due to the initial cost. Higher is also going to be the benefit that you're going to see in the time. So it's expected that at least initially, the introduction of a DevOps model is going to introduce a longer time to market, at least initially, right? That said, there's also an implication related to the cost, right? To get there with the DevOps model, you also have to face a possible high cost, right, to introduce the automation work, right? So you could be used to execute so many manual steps to get something done, and the introduction of a parallel thing like DevOps could also introduce an higher cost, at least initially. But this kind of thing does not have to get you worried about, right? It's just an investment that at the end will save you time and resources as well as money. And it's also related to culture, right? While introducing DevOps, you're going to get two different entities, two different business units working together, right? And so, yeah, a sort of collaboration or a sort of strict collaboration has to be created between those two teams, right? But even here, the good point is that both of those teams at the end of the DevOps implementation will have much more time to be focused on their real targets. As we said, manual processes impede DevOps velocity, right? So if you think to any kind of manual process, this kind of thing is going this kind of approach is going to get any kind of growth more complex, right? So if I'm today managing my infrastructure with manual processes and my infrastructure consists of 100 systems or 1,000 systems, if this kind of number is going to grow, and this is expected, right? It's expected to see the number of systems or the number of services going to grow. Yeah, your manual process or your approach with manual process is also going to become more complex, and at the same time, it's going to be more error-prone, right? And we know this kind of manual process is going to be tedious and time-consuming, right? Tedious also for many people that maybe could give their value to the company in a different way. As we said, it's something difficult to operate at scale, right? So if a manual process executed on 100 environment takes a fixed amount of time, the same kind of thing applied to the double or to 200 or 1,000 system is going to not scale at the end. It's going to require much more time than before. With manual process, it's also difficult to have a standardization there, right? Because if you think to more people managing your IT infrastructure, each of them will execute the manual process in a different way. And the final result could also be that you will get a different results on many different systems. And the result of this is that you also see a possible configuration drift on all of your environments, right? And here we also have a statistic coming from IDC in September 2021 saying that 61% manual processes are the number one bottleneck, right? So 61% of the people thinks that manual processes are the number one bottleneck while looking at the DevOps or the scalability into an IT infrastructure. We know that many administrators are able to build and leverage custom scripts or one-off custom scripts, right? And those solutions are today there in many places or for many companies. Also because in the past, those scripts have been able to solve different issues or the issue to perform different or repetitive tasks, right? But even this kind of solution has their several severe limitations. Yeah, first of all, again, it's something that cannot scale, right? The second point is the lack of control. At the end, the execution of a script that run on 100 system, 1,000 system is not going to give you a feedback related to the output or the result obtained by executing that particular script. Again, it could be error prone just because maybe the connection to one system or more system maybe does not work or something happened on that system and so the script didn't work. There's no standardization, again, just because at the end everyone could build a script, right, to execute an operation. And so as soon as there's a new script, maybe not all the people in the team are aware of that script, not all the people know what the script is going to do, and everyone in the team can also write something that maybe is not readable or is not comprehensive for all the others, right? It's hard to audit, right? It's very hard to understand if a script or a command had been already executed or not on a system. And at the same time, it's really hard to understand what happened by executing that particular script. And the final result is, again, a possible configuration drift that is there on all of your system managed in this way or managed by a custom script. And this is why in the Oracle Linux and virtualization team, we decided to introduce a new solution called Oracle Linux Automation Manager. Oracle Linux Automation Manager provides a modern provisioning, automated deployment, configuration management, and task automation into one unique web UI interface. This kind of solution is today part of the Oracle Linux portfolio. It's built starting from an open source project. So Oracle Linux Automation Manager is built on two main open source projects. So we have the management solution, so the UI to the entire solution that is based and built starting from the AWX open source project. And that said, we also have the Oracle Linux Automation Ansible core that is based on the Ansible open source project. And the cool point is that the entire solution, the entire Oracle Linux Automation Manager solution is included with the Oracle Linux Premier support at no extra cost. What does it mean? It means that today, all of our Oracle Linux customers can run Oracle Linux Automation Manager without paying any kind of extra to get it in place. Key capabilities of this solution. So this one is a role-based access control solution. What does it mean? It means that you have the opportunity to configure user groups and permission. So you can decide for each user that you're going to create, which kind of permission that user will have on your environment. So to give you an example on this, I'm part of the financial business unit, and I'm part of the DevOps team managing the financial solution that is there in my company. I will only get access to the systems part of my business unit. And I can also decide that a user can execute or maybe can only audit or can only check what is going on or what happened on all of those systems. You have the opportunity to configure and prepare of job templates. Job templates are definition and parameters that could be passed to a possible execution of a playbook. A playbook, at the end, is a set of instructions that can be executed on one or more systems. And the templates, the concept of template is the fact that you can pass some parameters. So to give you an example, I can create a playbook that is going to create one new user on a Linux system. And the parameter could be the username, right? I have inventory management. So the inventory management gives me the opportunity to possibly decide to run a particular playbook, right? So a particular set of instructions on a group of systems, right? And not just only one of them, or maybe I do not need, for example, to select an entire list of systems. I can create these kind of logical groups to then decide to execute a particular playbook only on that group of hosts. I have project repositories, right? So projects are a logical store where you can save and you can store your playbook, so the code that is going to be executed. And the interesting point or this interesting thing about project repository is that by leveraging this kind of option, everyone that is going to get access to Oracle Linux Manager will have the opportunity to understand and also see the possible contribution coming from others. Right, so I can, for example, build a playbook that is going to be interesting for a particular business unit in my company. That playbook will be also visible by all the other business units, and I will have the opportunity to possibly reuse that playbook to then maybe use in the same way on another business unit, or maybe get the same playbook and customize that to then execute something different on another business unit or on another inventory management, so on another group of hosts. I also have the credential management that is there into the same system. And this kind of thing is quite interesting while comparing, for example, to the manual script execution. With the credential management, with Oracle Linux Automation Manager, only the host where Oracle Linux Automation Manager is running will then get access to your systems, right? And this kind of thing is going to be important, because if we think back to the possible manual approach with custom script, that kind of thing also usually happens from the client, right? And at that point, you really do not have any kind of control or who is connecting to a system and what that person is going to do on the system. Here, the only actor or the only component that will get access to your systems will be Oracle Linux Automation Manager. And Oracle Linux Automation Manager will track all the activities that are going to be executed on all of your systems. So you will have a centralized management for credentials, as well as centralized management solution that share with you or show to you who is going to do what on all of your systems. And here we have an example scenario, right? Linux, is an important component that is there on Oracle Linux, and it's there on any Linux distribution. And here we have an example where, again, we have a playbook, right? So we have a set of instructions that is able to configure Linux on a Linux system. I have the opportunity to send the same playbook to configure 100 development servers by executing 2 free clicks. This kind of thing is going to be managed by Oracle Linux Automation Manager, that we send the configuration commands on all of those development servers. And this is a very quick example, because I also have the opportunity, for example, let's say that I would like to disable Linux on development environments and enable the same on production environment. Just to give you an example, I have the opportunity to execute the same playbook on all of the development environments by a specific parameter or a specific job template that will say to disable the Linux on that Linux system. And I will have another job template that is going to be applied with the same playbook on my production environment that will enable Linux on those. And this one is just a quick example related to a possible Linux configuration, because at the same time, Oracle Linux Automation Manager is a solution that can also interact with many other things, right? So Oracle Linux Automation Manager is able to automate many different things on a Linux system like Oracle Linux, as well as on other devices like firewall, network devices, storage, compute, and even software. So while looking at Oracle Linux Automation Manager, you can really think to a solution able to automate everything that can be manually executed, right? Yeah, and so to recap on the Oracle Linux Automation Manager solution, it's stable and reliable. It's there from many different years in the open source community, and it's today part of Oracle Linux and included with the Oracle Linux Premier support, so officially supported by Oracle. There's no extra subscription or licensing or cost to possibly get access and get the support to this solution. There's no real restriction on the number of managed nodes, so the number of nodes that you're going to manage with Oracle Linux Automation Manager. There's really a zero learning curve. It's very easy to switch from manual execution or from custom scripts to Oracle Linux Automation Manager. You have a centralized management interface. It's very easy to standardize using playbooks, also because, public available, you can even find many different playbooks coming from different communities, and you can decide to leverage those, customize those, or even build your own. And you also have an increased security, right, with role-based access control. But again, you can create how many users you want or you need, and decide which kind of permission, which kind of grants those users are going to get on a solution like Oracle Linux Automation. Now, I briefly introduced the solution that allows to automate whatever you want on an IT infrastructure. I'm now going to move over the multiple deployment options that we have there for IT infrastructure while looking at Oracle Linux, right? So today we have three main different image types for Oracle Linux. We have container images. Container images are there and built and released by Oracle. And those images can today leverage by standalone container tools, like, for example, Podman. Podman is a standalone container tool that we today support, for example, on Oracle Linux 8 and 9. Or you can also decide to leverage those container images on Kubernetes. And Kubernetes is there with Oracle Cloud Native Environment that I'm going to talk with you later. That said, we have cloud images. Those images are there mainly for the KVM hypervisor, but those cloud images are really generic cloud images, right? So those images can be leveraged with private as well as public cloud providers. The entire automation, right, relies on cloud init, so that it's the de facto standard automation for the cloud, and those images can today be leveraged, for example, with Oracle Linux Virtualization Manager, Oracle Linux KVM, or even on a generic cloud or third-party cloud vendors. Moving ahead, we have VirtualBoxes. Those images are there mostly for developers and are built to be leveraged with VirtualBox and Vagrant. Those images are there to allow to automate the creation of an Oracle Linux instance on your development environment on top of VirtualBox. I'm a fan and also a user of those boxes, of those images, just because at the end, by executing a single command or a couple of commands, you can get an Oracle Linux system up and running in less than a minute. And I'm going to even share with you a quick demo about this later. Coming back to containers, I briefly mentioned before the Kubernetes option that we have there with Oracle Linux. Today, part of Oracle Linux Premier support, we also have a solution called Oracle Cloud Native Environment. Oracle Cloud Native Environment gives you a centralized Kubernetes management and all of the enterprise feature required for a Kubernetes infrastructure, right? So over there, we have the container orchestration with multi-cluster support. We support more than one container at one time for Kubernetes. And you also have different capabilities like application definition and image build, service mesh, networking, storage support, high availability, load balancing. And all of those are part of Oracle Cloud Native Environment. And again, even Oracle Cloud Native Environment is today included with the Oracle Linux Premier support. So there's no extra cost even while leveraging the Kubernetes solution that we have there with Oracle Cloud Native Environment. We talked about cloud images. And it's also important to know that, again, with the Oracle Linux Premier support, you also have access to Oracle Linux KVM virtualization solution. This kind of solution relies on two main components. We have Oracle Linux KVM, where that relies on Oracle Linux 7 as well as Oracle Linux 8 with the unbreakable enterprise kernel. And over there, we have KVM user space components like QEMU and libvirt leveraged to run virtual machines. That said, we have a management solution called Oracle Linux Virtualization Manager. It's a solution built starting from an open source project named Overt. And again, even this one is offered as an additional program for Oracle Linux Premier support. That means that even the Oracle Linux KVM virtualization solution is part of the Oracle Linux Premier support. Public available, there's the full documentation library available for Oracle Linux KVM and Oracle Linux Virtualization Manager, where you can find all the details and all the features and capabilities that we have there with this kind of virtualization solution with Oracle Linux KVM and Oracle Linux Virtualization Manager. So we moved from container images with Oracle Cloud Native Environment, cloud images with Oracle Linux KVM, and Vagrant boxes with Oracle VM VirtualBox. As you maybe already know, we have announced VirtualBox 7.0. And into this new major release, we introduced a huge list of new features. We really did a huge job on this major release for VirtualBox. Just to mention some of them, we introduced a completely new 3D code where we also have DirectX 11 and OpenGL4 support for VMs running on top of VirtualBox. We have a full VM encryption. We improved a lot the integration with OCI. So with VirtualBox 7, you also have the opportunity to manage the OCI instances by the VirtualBox user interface. And over there, we also introduced many other minor enhancements, like, for example, a top-like tool for monitoring CPU and memory usage for each running VM. So you really have a chart that allows you to easily identify which VM is consuming or leveraging so many resources on your system. With Vagrant boxes and Oracle VM VirtualBox 7, as I said before, by executing a couple of commands, you can get, for example, an Oracle Linux system up and running in less than a minute. And now I'm going to share with you, for example, a quick demo where, and it's a demo running on a Mac. You will see that you're going to get in Oracle Linux 9, that is the latest major release we have announced for Oracle Linux this year. You can get an Oracle Linux 9 up and running in less than a minute. Yeah, so as you have seen in this demo, this one was on a Mac, so on Mac OS, and I got Oracle Linux 9 up and running in 58 seconds or 58 and a half seconds by executing two commands, nothing more than that. And this kind of thing can be also interesting for developers that obviously are not system administrators, and maybe for a developer, but even for a system administrator, installing an Oracle Linux 9 system could take at least 30 minutes to 1 hour, right? With this kind of solution, you can easily get an Oracle Linux 9 up and running in less than a minute, right? And I think that this is really, really amazing. Moving ahead, so we talked about Oracle Linux Automation Manager as the solution to possibly automate all the manual steps, right? And a manual step could also be installing an operating system like Oracle Linux, right? We then introduced all the image types that we have there for Oracle Linux, container images, cloud images, and Vagrant boxes for Oracle Linux. If you think to Oracle Linux Automation Manager applied to those images, you can really automate and deliver automation with Oracle Linux and automate the deployment of your services, of your systems. And as you can see from this slide, if you think to Oracle Linux Automation Manager, apply to Oracle Linux, apply to Oracle Linux KVM, apply to Oracle Cloud Native environment, you're going to obtain agile IT operation, right? Because you can create and reuse playbooks to automate tasks. So, and when we say automate tasks, it does not only mean automate the Oracle Linux installation, right? Task could be install an operating system like Oracle Linux, and the following task could be deploy my application or install my application. And the following processes in the time could also be update my application. Yeah, it's important to know that with Oracle Linux Automation Manager, you're also going to use a simple human readable automation, the YAML format, right? And you're going also to get access to a new decentralized architecture with modular deployment. You will have the opportunity to introduce a standard for your infrastructure across all IT estates, right? You will also get access, for example, to a possible control on the configuration drift. Playbooks can be re-executed, right? And the re-execution of a playbook will say to you, for example, if that kind of configuration was already in place, or maybe there was a drift. You will have a solution that will make outcomes and tasks auditable, versionable, repeatable, and recoverable, right? A playbook can always be re-executed if something does not work. You always have the opportunity to repeat a playbook on a particular system or in a particular group of hosts. Everyone in the team or everyone in the IT infrastructure will have the opportunity to capture or possibly incorporate best practices coming from others. You're going to get a solution that will give you cluster support and high availability. And it's going to be a solution that will scale and will continue to be flexible based on your requirements. Yeah, and between the final results, you're also going to obtain an increased security and compliance. You will be sure that your system will be secure and optimally configured, right? Because a playbook, as we said, a playbook can apply a change, but the same playbook can also check. So you can also build a playbook able, for example, to check that a particular or a prefixed configuration is in place on your systems. Increased security also because you will have the opportunity to define roles or groups to control what users are allowed to modify or change or to execute on your systems. And you will also have a solution that will allow you to quickly remediate from deviation, quickly remediate in case of issues, or quickly remediate if a policy or a critical setting is not in place on your systems. Even, for example, there's a new security fix that has to be installed on all of your systems, right? By building a playbook, you will have the opportunity to quickly remediate and get that kind of particular security fix installed on all of your systems. So I would like to obviously thank you for the time that you dedicated to this session. I also want to leave you for the next steps, or as the next steps, some links where you can get access to more information about this. We also have on GitHub there a training station where you can also get access to different recordings, different videos that show you how to leverage Oracle Linux Automation Manager, how to get the same applied to your own environment, and some blogs where at the end you can find different articles related to product announcement, as well as technical steps or examples that could also maybe be interesting for your IT infrastructure. That said, I would like to thank you again for the time. My name again is Simon Coter. I'm there on different socials. Feel free to reach out if you have any question, and I'd be glad to possibly help you on leveraging Oracle technologies. Thank you.